Hello and welcome. We'll be carrying out a practical to prove Thevenin's theorem, which states any complex circuit between two terminals can be replaced with a single equivalent series circuit consisting of a Thevenin voltage Vth and a Thevenin resistance Rth connected between the same terminals. It is circuit analysis theorem used to simplifying circuits. So for the circuit above, we are going to determine the Thevenin's circuit equivalents. Equipment and materials required. We have our power source and our breadboard. So this is a power source where the breadboard is mounted on it. We have our digital multimeters. So we're making use of two digital multimeters. One for our voltage measurement and one for our currents. Then we have our resistors, making use of 4 resistors. So with their 1.5 kilo ohms resistor and 1 kilo ohm, so 2 each, as required from our circuit diagram. Then we have jumper wires to create connection for our circuit. So first, let's determine the Thevenin's equivalent by calculation. You can set the formula to get the voltage equivalent, voltage Thevenin equivalent, and resistance Thevenin equivalent. And here is our resistance equivalent and our voltage equivalent after calculation. So this is the part we are going to be carrying out our practical to prove and get the corresponding Vth and Rth. The first step is to measure our input voltage. So switch on our power supply, adjust our multimeter to the DC voltage range, and let's measure the voltage, our input voltage. So place your probes at the terminals of the input voltage. So we have 15.2 volts approximately. So the jumper wires have used to create a connection to the breadboard. Our circuit is ready. We have our resistors mounted, our 1K and 1.5K ohms resistor. We have our terminals, terminal A and B, and ready to be measured. From our circuit, so let's take our measurement. So before taking the resistance measurement, make sure you switch off the power source, and let's measure from the two terminals the equivalent resistance. So we have 2.78. so that is our resistor Rth. Then we switch on our power supply when taking our voltage equivalent, which is the Vth, and we measure across our terminals, so terminals A and B. So adjust your multimeter to the voltage DC range and let's measure. So we have 7.75, 7.78. so that is our Vth. So comparing our calculated value, you can see that we are correct, and our resistance is just slightly higher because this is due to the tolerance of the resistor we used, but we are correct, and we have successfully reduced the circuit into a Thevenin's equivalent circuit. Thank you.